Everyone. Today we are going to solve LeetCode problem 874, walking robot simulation. So a robot is on an infinite XY plane, starts at point 00 facing north. The robot receives an array of integers, commands which represents a sequence of moves that is it needs to execute. There are only three positive types of instruction the robot can receive. -2 for turn left 90 degrees and -1 to turn right 90 degrees, and k, which is lies between 1 to 9, move forward k unit, 1 unit at a time. Okay, some of the grid sequence are obstacles. The ith obstacle is at grid point obstacles I, xi, yi. If the robot runs into an obstacle, it will stay in its current location on the block adjacent to the obstacle and move on to the next command. Return the maximum squared Euclidean distance that the robot reaches at any point in its path. Okay. So let's break down the problem. So basically, it says there is an infinite xy plane. The robot initially situated in the origin 00, facing towards north. Okay, the robot receives an array of commands. Okay, there are three types of commands. -2 for turn left 90 degrees, -1 to turn right 90 degrees, and move forward k unit. Okay, and also there are some obstacles. Okay, if a robot run into an obstacle, it will stay in its current location on the block adjacent to the obstacle and move on to the next command. Okay, return the maximum squared Euclidean distance, that is x square plus y square. Robot reaches at any point in its path. Okay. And there can be an obstacle at 00. If this happens, the robot will ignore the obstacle until it has moved off the origin. However, it will be unable to return to 00 due to the obstacle. Okay. North means plus y, east means plus x, south. Okay, okay. Okay, so basically, what is the idea here? Basically, we have xy plane. Sorry, this is x and this is y. Okay, and this is origin which is 00. So robot is initially here. So the robot can have three type of version: turn left, turn right, and move forward. Okay. So basically, what we are going to do, we are going to simulate the process and are going to find the maximum squared Euclidean distance for each point it reaches throughout its journey. So for that, what we are going to do, we can use a direction vector, like a direction variable, which will indicate like in which direction the robot currently is now. And for like moving it forward, we can use to like if the robot is currently at xy point and it move 1 unit towards the east, what will be its current position? New position, it will be x plus 1 comma y. So how much it increases throughout its x, it 1, and y is 0. Like, so we will create two vectors dx and dy, like which will indicate if I move towards certain direction, how much x will increase and how much y will increase. So let's write it in the editor, and then we will try to understand this. So let's consider four direction are east, south. I'm basically writing it in cyclically. So south, west, and north. Okay, east, south, west, and north. Now we will create two vectors dx of size 4. So for east, if the robot moves towards it, how much it x coordinate will increase? It will increase by 1. For south it will 0, for west it will -1, and for north it will 0. And similarly, we will create another array dy, like the changes in y coordinate. For east it will 0, for south it will -1, for west 0 and 1. Okay, and also, yeah, that's good, I think. Now here we will create a set to check if any obstacle is present in a certain coordinate or not. So let's name this as obvious. Now we will load this, load the point into this set. Okay. We will insert the coordinates of the obstacles and give v0 comma v1 in the set. Okay. Now here we will create answer, store answer, direction. Initially the robot is facing towards north. So the for the north it is like we will indicate direction as index, like we whatever index it will denote, it will be like that will be its direction. So initially it is north, which is index 3, 0, 1 to 3. So we will initially put it as 3. Now we will store the x and y coordinate. Initially the robot is in the origin, so is 0, 0. Now we will uh, command we will basically process the commands one by one. So if the operation is -2, so what does that mean? It means we have to turn left. So what does how we will turn left? Like if I am if the robot is going towards east, like this is the direction, this is north, this is east. So if I am facing east, if I rotate towards left, it will be north and then west, then south. So if you look carefully, if I am at east and like if I move backward, it will act like I'm rotating towards left. Like initially I'm north, if I rotate left side, it will west, then south, then east. And similarly, if we move forward cyclically, it will be similar to rotating 90-degree towards right, east, south, west, north. So for turning left, we have to just move backward. So how will we move backward? So we have a direction. So direction equal to direction -1. We will like uh, go one step back in the direction list, but be careful like this. While we will go backward, it may like go out of the bound in the left side. So for that reason, what we can do, we will mod this with the 4. There is also problem like whenever it will become negative, the modulus will stay negative, but we also have to access the indices here, so it can't be negative. So we will add a +4 here. Uh, and similarly, if operation equal to -1, basically we will turn right. So for turn right, we have to just add this direction +1 mod 4. And that's all. And otherwise, we have to move operation steps. So while operation minus minus, what we will do first, we have to check like whether we have encountered any obstacle or not. So for that, we will just query if in the set of the obstacle, if it contains the point. So basically, what will be the new point? Like, I mean, currently at x and y, and if I move one step forward, it will be like x plus dx of direction, comma y plus dy of direction. So if the say obstacle is already there, so we will just simply break. Otherwise, we will just add the value. Means we will move one step forward, and for every step we will just calculate the best possible answer for that. X square plus y square, and we will simply return answer. So this should work. Let's check this. Okay, command, so typo, origin typo. Let's run this. OPS dot contents. Expected a bracket. Okay, let's test these on the samples. Okay, the samples passed. Uh, let's also simplify this, like -1 plus 4 is plus 3. It doesn't matter, but let's simplify. It will obviously pass on the sample, but let's submit this to check is it correct or not. Yeah, it got AC, so it is correct. So what is the time complexity of this program? Like here we are using a set, so basically it is like n log n if the size of the obstacles is n, which is good, I think. Yeah, good. Now we are processing the operations. So in the first kind of operation, we are just taking constant time. In the second kind of operation, also we are taking constant time. Time complexity, just we are rotating towards left or right, depending on the operation. And for the third case, we are like moving k step forward. So we are taking k time. So here the value of the k is very small, like from 1 to 9. So in the worst case also, like if the size of the commands is n, and in every command we are moving the maximum amount of steps forward, so in that case also it will be 9n, so which is equal, like which is basically linear time complexity order of n. So the time complexity is like order of the size of the operations, and uh, like n log n if the size of the obstacles is n. So this is my approach. So that's all. Thank you for today. Thank you.